everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 36 is on the screen. See how you do with that. Yesterday I went over it. Hopefully that clarified some things. Numbers 1 through 5. I'll give you some time. Copy and go. All right. So, start with number 1. Let's see. Help us with number 1. How about Anthony? D. What do I do first? Multiply everything by 6. Everything or the numerators? Numerators, yes. Because if we put this over 1, 1 multiplies the denominators. All right. So this is 18 over 2x plus 12 over 3 equals 30 over 6. Yes, so far so good, yeah. Simplify, this is 9x plus 4 equals 5. Subtract 4. We end up with 9x equals 1. Divide by 9. X equals 1/9. Hands, have you got that? Some of us, yes, all right. So far, so good. Let's go to number 2. Factors for number 2. You already shared with your neighbors, yes? Yes, Mr. Q. All right, Anthony, pass someone. X plus 8, x plus 3. Hands, have you got that? That is correct. Number 3. This is a little bit challenging, but I think you got it. So, share with your neighbor your factors, and then Clarice is going to pass to someone. All right. Pass someone, Clarissa. Bailey, what'd you get for factors? Repeat that again. X plus 10, x minus 10, almost. 3x. 3x cubed plus 10, and 3x cubed minus 10. Hands, have you got that? Oh my goodness, computer. So how do we get there? First of all, is it in standard form? Yes. What was the red flag? The minus. So can we take the square root of this? Yeah, what two numbers multiplied give me 9x to the 6th power? That would be what? 3x cubed times 3x cubed. And then what is square root of 100? 10 and 10 plus minus. All right. Number 4, y equals what? Y equals what? Pass someone, Bailey. Y equals what? 1x plus 4? 1x plus 4. Hands, if you got something like that. Close. Check with the neighbor, see what you're going to change from that equation. What changes? We want to pass it to Jacob to enlighten us. What changes? Jacob. The what? Yeah, it's minus 4. All right. Anything else? And it's supposed to be what? 3x. Yes. Hands, have you got that? All right. And our table, x, y, negative 2. Let's see, negative 2 times 3, that's negative 6. Minus 4, that's negative 10. 0. 0 times 3 is 0. And that leaves us with negative 4. And then 1. 1 times 3 is 3. Minus 4, that's negative 1. And our graph. First point is at negative 2, negative 10. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere over here. 0, negative 4. 0, 1, 2, 3, 4. and 1, negative 1. There you go. Hands if you got something like that. Yeah, by now the graphing should be coming along, okay? So, talking to your neighbor, how many blocks on the 8th figure? And ask them how did they got that. How did they get whatever the blocks in the 8th figure? Talk it over your neighbor, please. All right. Let's see, how many blocks in the 8th figure? Brandon, Doherty. He went straight to the last part. He said n times n plus 1, which means n squared plus 1. Hands, have you got something like that? All right. So instead of n, what do we replace, guys? 8. So what is 8 squared? Plus 1, 65. That is correct. All right. Copy the agenda for today, and you make sure you send me your warm-up, please. Warm-up number 36, just finished. Product and quotient of rational expressions. Home plate tonight is only 20 problems, only. We're going to start here, though, so we can go a little bit faster. And I'm going to split it up. I'm probably just going to leave you by either the odds or the evens. We'll check them out right now. Also, do me a favor, as soon as you're done copying the agenda, getting a blank sheet of paper ready, get your cell phones out really quick. Go to Canvas. Go to our class. Grades. And take a screenshot. Get that signed, brought back tomorrow. Bah! That's your quarter grade. First quarter done. Let's go. All right. So once again, we finished warm-up number 36. Today we're continuing with product and quotient of rationals. And tonight's home plate, only 20 problems. Like I said, I'm probably going to leave you odds or evens. I'll check right now. And here's your code for the home plate for tonight. J9MYT. J9MYT. Now, last night's home plate was from your textbook, yes? Pages 438 and 440. Go and turn that in on Canvas. And I am going to take a question from the home plate. There was only 7 problems. I'll wait for you to turn it in, and then I'll take a question, and then we'll move on to the last portion of this session. So if you notice problems A, B, C, and D are the only ones that required the excluded value, right? Not the division ones. All right. So with that said, which problem would you like me to go over with you guys? A, B, C, D of multiplication, or A, B, C of division? Any of them? Pretty straightforward. Questions, comments, autographs? No? No autographs? Okay. We got it? Let's go. Okay. So, and I think we got this. We have geniuses in this class. So tonight's home plate is these 10 and these 10. But like I said, we're going to split them up. I just need to cover a couple things with you before we move on. So get a Cornell in front of you. I want to address one thing really quick. and write example MJQ, Michael Jordan Q. All right. So, copy this problem down. We got x squared minus 9 over x squared plus 5x plus 6 times 2x squared minus 8 over x squared minus 9x plus 14. All right? So we're going to multiply this. So tell your neighbor the first thing to do. What do we do first? What do we do first? Make sure we got the process down. Tell your neighbor. First thing to do. All right, Anthony D. Factor everything. Okay, so numerator. Tell your neighbor the factors for x squared minus 9. Factors for x squared minus 9. Noah? Close. Square root of 9 is 3. X plus 3, x minus 3. Oh, I wrote 9. X plus 3, x minus 3. All right. Denominator. Factor this one. 6 and 5. Factors of 6 that add up to 5, everyone. 2 and 3. 23, Michael Jordan. X plus 2. X plus 3. Times. Look at the second numerator. All right, factor. All right, first thing we check is what? Standard form, then GCF. What is GCF? 2. So I'm going to write it here first before I bring it down. 2, and that leaves us with x squared minus what? Minus 4. Okay, so I'm going to bring down the 2. And tell your neighbor the factors for x squared minus 4. What are my factors for x squared minus 4? Yeah, x plus 2, x minus 2. All right, let's factor the denominator. So, what two factors of 14 add up to negative 9? Factors of 14 that add up to negative 9. Tell your neighbor, please. Two numbers. All right. Trinity, go. Ah. Negative 2 and negative 7. So x minus 2, x minus 7. All right. So yesterday, step 1, we're done. Step 2, we needed to multiply numerators times numerators, denominators times denominators. And we said, start with numbers first. What's my first number? 2, and then we write x plus 3, x minus 3, and then x plus 2, x minus 2. So basically all the numerators. Denominator, x plus 2, x plus 3, then x minus 2, x minus 7. So we're done multiplying. Right, Anthony D? And what are my giant ones? Everyone? X plus 2, okay. This one and this one. What else? X plus 3. What else? And x minus 2. So what do we have in the numerator? This and that, so that is 2 times x minus 3. And denominator, x minus 7. All right, from 1 to 5, I'll comfortable are you with this so far? Yeah? Okay. So, underneath that, copy this next one, please. Example Star Wars cubed, x squared minus 9 over x squared plus 5x plus 6 times 2 x squared minus 8 over x squared minus 9x plus 14. All right. Step 1, factor. So once again, tell your neighbor factors for x squared minus 9, factors for x squared minus 9. Yes? The same one? So the factors are x plus 3, x minus 3. Oh, I wrote 9 again. Come on, Noodle. Catch up. Factors for the denominator. X plus 2, x plus 3. Times. Factors for the numerator. 2 times x plus 2, x minus 2. Factors for the denominator. X minus 2, x minus 7. Some of you are like, what? Here goes the second method. Look up to the screen, writing utensil down. You finish copying a little bit. So let's go back to the first method. First method, we factor completely, which is good. Then we multiply, which means writing all the numerators and all the denominators together. Whereas this second method is very similar, except for, look up, once you have your factors before you multiply, we can actually simplify. So, can I simplify this fraction? Yes. Can I simplify this one? Yes? Then we multiply. What do I have left on the numerator? 2. What else? X plus 2. What else? X minus 3. X plus 2, x minus 7, and we identify any giant ones again, and we're left with 2x minus 3, x minus 7. Did we get the same thing? Yeah. So here I'm going to give you guys a little bit more liberty to be simplifying as you go, and that only works for multiplication or division. Okay? So copy that, second method. And this just expedites the process a little bit more at times. All right, so before we move on, talk it over with your neighbor, let them know the first method versus the second method. What's the only thing that changes? First method versus second method. First method versus second method. Bless you. All right, send me your notes. Let's see what you did. All right. So our objective for today, I can master multiplying and dividing rational expressions. I can master multiplying and dividing rational expressions. Today we're going to be done with rationals. If you think about it, we already did addition and subtraction. We did multiplication and division. Today I'm just going to give you extra practice But I do want to get to one more portion, which is the closure portion. And in regards to different types of numbers, and this is just to check and to keep us in mind certain numbers remain the same for each operation, I guess, in regards to their identity. So watch. Look up to the screen. We covered rational expressions, yes? Do we know what they are already? Yes? Tell your neighbor in your own words what rational expressions are. What are rational expressions in your own words? We got it? All right, good conversations. Type in the definition on your screen, please, in your own words. Don't look at the notes. By now you're experts. Let's move on. So we got that down. We talked about the steps, and we know the only different step from division to multiplication is that you need to multiply the first fraction times the reciprocal of the second. All right, so let's talk about closure. Look up to the screen. It says that a set of numbers is closed or has closure when whatever operation you apply to them, the result gives us the same type of number. For example, let me pause the tunes in the back so we can focus. Check this out. Counting numbers. All right, so give me a counting number, Anthony D. Very good. 23. Is that a counting number? Yes. How about another one? Plus, and then Anthony D said 1. All right, the result gives us what? 24. Question, is 24 a counting number? Yes, that means that under addition, counting numbers are closed. That's what it means. That if you start with a counting number, you apply an operation, if at the end you get the same type of number, it's closed. Let's go to subtraction. Give us another number, Anthony D. 20. Minus, let's see, Jaden, 5. That gives us 18. Is that close? Is 18 a counting number? Yes. Would it give us a counting number every time? How about if I do this? 5 minus 23. What number is that? Negative 18. Is negative 18 a counting number? No. So this is not closed, because at the end we get an integer. How about multiplication? 23 times 5. How much is 23 times 5? Anthony D. Very good. 115. Is 115 a counting number? Will that work all the time? Let's double check. 5 times 23. Yeah, 115. So this is what? Closed. Next, 23 divided by 1. What is that? 23. How about 1 divided by 23? What is that? 1 over 23. Is 1 over 23 a counting number? So this is what? Not closed. Yes? All right. So on your paper, I want you to try with whole numbers. Try with whole numbers and see under addition, subtraction, multiplication, and division, and just let me know if they're closed or not closed. And I'm going to send you a screen so you can send me your notes as soon as you're, just write the row whole numbers, and then try addition, 2 different whole numbers, subtraction, 2 different whole numbers, and so on and so forth. I'll give you some time. Go. All right. So let's see. Brandon, Felix, what did you write for your whole numbers for addition? What were your numbers? 2 plus 23 Michael Jordan. That's 25. And by the way, remind your neighbors, what are whole numbers? What are whole numbers? What are whole numbers? And then Brandon's going to pass it to someone so they can enlighten us. What are whole numbers? What are whole numbers? Brandon, pass someone. Martin, what are whole numbers? Did you ever hear that? He said, all the counting numbers, but including now 0. So 0, 1, 2, 3, 4, and all those numbers. Okay. So is it closed under addition? Looks like it. Let me try 0. What is 0 plus 23? 23, so it is closed. All right. How about subtraction? Is it closed under subtraction? Let's see. 2 minus 23. That gives us what? Negative what? 21. Is it closed? No, it's not closed. How about multiplication? About 23 times 0. 0 times 1, and so on and so forth. Okay, so it is closed. How about division? What'd you write for division? Rylan. (23) divided by 1? Wow, we already have that one. Okay. All right. 1 divided by 23 is still 1 over 23, and it's not close because it gives us a rational. Okay. So we get the idea, right, where we're going with this? So for tonight, I want you to come up with an example for rationals. Rational expressions or rational numbers for for addition, subtraction, multiplication, and division, and to see if they're closed, okay? And if they're not closed, give me the example of not being closed, all right? So that's it. Let's go back to these. So which ones do you guys want for home plate, evens or odds? Look at the other ones, evens or odds. Jacob, pick for your class. No pressure. Odds, all right, so that's your home plate. Copy number 2 on your paper. We're going to be doing some practice here in class to make sure we got it. We're working on number 2. Number 2. All right. So, tell you the first thing you're going to do. First thing we do. I'm using red just to practice. Jacob, pass someone. Danny, first thing we do. You ever hear that? He said since it's division, we multiply the first fraction times the reciprocal of the second. Yes? All right, so we're done with step 1. We go to factor, step 2. So, what are the factors of the first numerator? Pass someone, Danny? Anthony E., factors for this one? Actually, this is just a monomial, so the 8 could be written 2 times 2 times 2 times x. About the denominator, can we write 3 any other way? No, that's it. 3x times, how about the 7? Just 7. How about the 4? 2 times 2. So here's a question. You guys want to multiply write it all, numerators and all denominators, or do you guys want to simplify first each fraction? What do you guys want to do? Simplify? Okay. Any giant ones on the first fraction? All right. How about the second one? No. Now we multiply. So we got 2 times 2 times 2 times 7. And over here we got 3 times 2 times 2. And we check again, any giant ones. 2 and the 2, so we're left with 14 over 3. Let's go to number 4. Copy number 4. Let me zoom in. All right. Is this division? No, it's not division. So this one is a little bit straightforward, but we still go. What will be our first step for multiplication? Tell your neighbor, please, and then we'll have Martin enlighten us. First step for multiplication. Martin, first step. Factor. So what are the factors of the first numerator? 3 times 3 times m. How about the denominator? Dom. Times m times m. Yes. Times. 7 is 7. 2 is 2. You guys want to multiply or simplify first? Simplify? All right. So one set of n's. So that leaves us with 3 times 3 times 7 over 2 times 5 times m. Any other giant ones? No? So our answer is, what is 3 times 3 times 7? 63 over 10m. Let's do another one. Example number 6. I'm going to give you a head start for number 6. It's very similar to number 2, the first one that we did. 10p over 5 divided by 8 tenths. Give you a head start. Go. All right, number 8. Once again, I'm going to zoom out. Seven over 10 times n plus 3 divided by n minus 2 divided by n plus 3 n minus 2. So let me zoom out. And let me move this over. All right. Tell your neighbor, what's the first thing we do with division? First thing we do with division. Make sure they got the process. First thing. Who went last? Anthony E. Was it you? You went last? No? All right. Anthony E. First thing we do. Multiply the reciprocal of the second. So it's 7 over 10 times n plus 3 times, we flip this, and that gives us n plus 3, n minus 2, over n minus 2. Okay. Next, we can simplify or we can multiply. What do you want to do? Simplify or multiply? Since most of them are already factored, right? Just this one becomes what, guys? 2 times 5, right? Okay. So what do you want us to do, Anthony D? Did everybody hear that? He said giant 1 of n minus 2 and n minus 2. Anything else? No? All right. So then we go this direction. What's left on the numerator? 7 n plus 3. How about the denominator? 2 times 5 times n plus 3. Can we simplify again? Yes, which is what? This one, and we're left with 7 over 10. Hands if you got that by yourself. All right. Yeah, we're getting there. Do another one. Number 10. Copy that one. Number 10. Let me move it up. That one's not division. That one is multiplication. All right. Do I zoom in? There it is. All right. So I'll give you guys a head start for that one. See how you do. And I'm going to pick someone. If they got it, we're done. If not, we do one more. How about them apples, yeah? Yeah? All right. I'll give you guys a head start. Go. So, what do I do here? Anthony, D, pass someone. If they got it, we're done. If not, we do one more. Yes. And I'll give you guys passes. That's fine. Brianna, what do I do? Factor. Okay, so what did you factor here? 2 times 3 times x. All right. This one as well, 2 times 3 times x. And what do we do from there? Pass someone. Oh, here. Did you ever see that? Multiply, then this with this, and then this with this. Answer, x plus 4. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.